Hello, everyone. My name is TyDavis, and this is my capstone defense. My paper examines how AI-assisted drone system changes the risk profile of military operations compared to traditional human-controlled drones while they're using in Ukraine as a primary case study. I'll cover the research questions, methodology, lectures, and gaps, the Ukraine case study results, including my risk framework, and close with conclusion and five recommendations. Ukraine is the first large-scale, real-world test of AI assistance in active combat. Both sides are using them at a scale never seen before. AI drones offer real advantages: fast reaction time, longer endurance, and keep operations while communications are jammed. The problem is, Ukraine is also one of the most electronical hostile environments on Earth. GPS is being spoofed, signals are jammed. Um, Everything that electronic warfare is happening in Ukraine right now. An AI system depends entirely on what it was trained to do. If it wasn't built for GPS net operations, it fails. And the goal of the study is to not say AI drones are bad, is to understand what new risk they bring, so we can address them before those risks cause more harm than the technology is worth. The central question is, how do AI system drone system change the vulnerability and risk profiled compared to fully human control system as seen in Ukraine? Um, for some questions is, what electronic warfare types hurt AI performance most? Uh, when are AI targeting systems most likely to fail? Does removing human from the loop uh, increase risk? And what are the biggest gaps in current law, doctrine, and technology standards? Um, I use a qualitative approach for my paper. This is approach because the research question is about the nature of risk, not measuring it statistically. And qualifying AI drone failure rates would require classified data that I can't have, and probably most people don't even have in the higher ups. Ukraine serves as a case study because it's the most extensive real world development of AI assisted drones in active warfare to date. Sources include academic journals, uh, RAND, NATO, CSIS, Atlantic Council reports, and open source conflict documentation. Uh, the the three risk categories are electronic warfare, AR targeting failures, and escalations. Were not permitted. They emerge from the literature itself. Four key findings from the literature: uh, RAND found GPS dependent AI navigation is a structure vulnerability, not a technical limitation. Uh, Goodfellow and um, what's that word? Four key findings from the literature is RAND found in GPS dependent AI navigation is a standard vulnerability, not a tactical limitation. Uh, Systems can produce conflict wrong answers while inputting are uh, manipulated, which in a targeting context means a false sense of certainty that leads to a bad strike. Johnson and Kellenborn show that AI decision speed compress the window where de-escalations can happen. Uh, Sakari and CNAS both uh, argue hybrid models, both argue hybrid models where AI assistance but human retain lethal authority are the most defensible approach. Five gaps emerged. No real comment performance data exists publicly. No electronic warfare resilience standards for AI drones. International laws hasn't catched up, and adversarial exploitation in the field is undocumented, and no shared allied doctrine exists for joint AI drone operations. Three things the conflict has already shown. First, GPS spoofing is the dominant electronic warfare threat. Russian feeds false GPS signals to redirect Ukrainian drones, so they land on the wrong side of the front line. AI systems built assuming GPS would always be available and have been the most vulnerable. Second, targeting errors are happening. CSIS document strikes on untamed targets is messy, but the finding that matters is that the volume of operation has made meaningful human oversight nearly impossible, regardless of whether AI or human error cause any uh, certain incidents. Third, the technology development race itself is the biggest escalation driver. New AI capabilities get pushed into fielded systems within days of development. No testing cycle, no doctrine review, no legal assessment. The pattern is what makes the conflict a warning for every future conflict where the technology gets deployed. Three original findings that extend beyond any single source in the literature is finding one electronic warfare vulnerability is a structure uh, design failure, not just a technical limitation. Is predictable documentation and still unaddressed at a scale. Finding two, AI targeting failures are not edge cases, the conference problem, where a system looks equally certain whether it is right or wrong, means operators under time by pressure bypass human judgment, even in a normal human in the loop setup. Finding three, the most escalation dynamic in Ukraine is the technology development race, not automation system firing at each other. This is not established in the pre 2022 literature, and is the most original research of this. Uh, the the risk framework is the original analysis contribution of the paper. It shows how AI and human system differ in kind of across all three risk domains, not just uh, degrade on uh, electronic warfare vulnerabilities. Human resistance is adaptive. A pilot who loses GPS improvise. An AI resistance is fixed at a designed target. When input fails in a way that the system wasn't built for, it degrades, is rapid, and often total. On a targeting failure, human errors are inconsistent and manageable through training and oversight. AI targeting errors are systematic, reproducible, and can be uh, delegibly engineered by adversaries who understand the system's architect. On escalation, human escalate through decision under stress, migrate by crisis protocols, and AI escalations, though compress decision cycles and a technology race that pushes unvetted capabilities faster than doctrine or law can follow. Ukraine provides the race mechanics is currently the dominant driver. In conclusion, we have four conclusions. AI drones are more brittle in electronic environments than anyone expected before. AI targeting can make conflict mistakes a human would catch through hesitation or intrusion. The government gap, there is no legal standards, no agreed doctrine, no technical backgrounds. This is the most important single finding I found. And Ukraine turned everything theoretical into document operation reality. The lesson is not that AI drones are too dangerous. It's the deployment them without adequate standard creates predictability, preventable, and problems. Some recommendations is set electronic warfare resilience standards. If a system can't prove it works without GPS, it shouldn't be deployed where GPS is under attack. Keep humans in the loop for lethal targeting decisions. Uh, Codify the project operation pressures, makes it political difficult. Invest in AI training. Red teaming should be mandatory before and any AI drone system gets operational approved. Push for international legal frameworks. Countries leading on the technology have the responsibility to shape the rules, build a shared allied doctrine, and NATO needs a common playbook so allies in the same battle space are working from the same rules of engagement. Um, any questions and discussions? I want to say uh, thank you, and I hope you learned something and enjoyed my capstone.